Sources of radio waves and radio waves in space. Radio waves and radio emissions are a type of electromagnetic radiation that can be observed at a range of frequencies, from a few kilohertz to many gigahertz. These waves are commonly used in communication technologies such as radio and television broadcasting, as well as in scientific research to study the properties and behavior of matter and energy in the universe. One of the most important sources of radio waves and radio emissions in the universe is the cosmic microwave background, CMB, radiation. The CMB radiation is a remnant of the early universe, and is thought to have been created during the Big Bang. This radiation can be observed at a frequency of around 160 GHz, and provides important insights into the early history and evolution of the universe. Another important source of radio waves and radio emissions in the universe is active galactic nuclei, AGN. AGN are powered by supermassive black holes that are located at the center of galaxies, and can emit radio waves and other forms of electromagnetic radiation at a range of frequencies. The study of AGN and their properties is critical for understanding the formation and evolution of galaxies, as well as the behavior of matter and energy under extreme conditions. In addition to AGN, other sources of radio waves and radio emissions in the universe include supernova remnants, pulsars, and interstellar gas and dust. These objects can emit radio waves at a range of frequencies, and provide important insights into the properties and behavior of matter and energy in the universe. Moreover, the study of radio waves and radio emissions in the universe has important practical applications in fields such as astrophysics, cosmology, and communication technologies. By studying the properties and behavior of radio waves and radio emissions, researchers can gain insights into the origins and evolution of the universe, as well as develop new technologies and techniques for communicating information over long distances. For example, the study of radio waves and radio emissions from distant galaxies and other objects in the universe can provide insights into the nature of dark matter and dark energy, which are thought to make up a significant portion of the universe but which are not directly observable using traditional observational techniques. In addition, the study of radio waves and radio emissions has important implications for the development of communication technologies, including satellite communications, GPS systems, and wireless networks. By understanding the properties and behavior of radio waves and radio emissions, researchers can develop new technologies and techniques for transmitting and receiving information over long distances. Another important source of radio waves and radio emissions in the universe is the Sun. The Sun emits radio waves at a range of frequencies, and these emissions can provide important insights into the behavior and properties of the Sun and its atmosphere. For example, radio waves emitted by the Sun can be used to study the structure and dynamics of the Sun's corona, which is the outermost layer of the Sun's atmosphere. The study of the corona is critical for understanding the behavior of the Sun and its impact on Earth's climate and environment. In addition, radio waves emitted by the Sun can be used to study solar flares, which are explosive events that release enormous amounts of energy and matter into space. Solar flares can have important implications for Earth, as they can cause disruptions to communication technologies and power grids, as well as pose a threat to astronauts and satellites in space. Moreover, the study of radio waves and radio emissions from other planets and moons in our solar system can provide important insights into the properties and behavior of these objects. For example, radio waves emitted by Jupiter's moon, Io, can be used to study the presence and behavior of volcanoes on the Moon's surface. In addition to natural sources of radio waves and radio emissions, there are also artificial sources of radio waves that are used for communication and other applications. For example, radio waves are used